This is Andy from HowEFIWorks.com, and today I'd like to show you the value of scatter plots and target AFRs. What I have loaded is a race car. This happens to be a 4-cylinder Volkswagen running a typical log intake manifold similar to stock intake manifolds. It has four fairly large injectors. I think they're 42-pound injectors. And this is the typical view that you would look at, where in red is your target AFR and in white is your AFR. And you can see it's generally staying close, but it's somewhat random. It's tough to see what you're looking at in that view. But what we do have is this thing called scatter plots. The third tab over right there. We'll go ahead and hit that. And what this is showing all the data for the entire drive or ride or whatever. And I have it zoomed in at about 1800 RPM up to about 7900 RPM. This is a manifold air pressure of about 30 or 30% air. This area would be a downshift, and full throttle is up here on this top line. In the color, what I'm displaying right here is the AFR 1 target. And what that is the AFR that we'd like to see at that part of the pressure map. This is essentially your VE table, but it's the dots where the color is what AFR you're shooting for. On the right is the AFR we actually got on average when we got to that point. I have a filter turned on. You can see this red around the box right there. I'm going to go ahead and open that up and show that I'm pulling out where the AFR is out of range, basically startup. And I can go ahead and take out transients, which is when the motor is changing RPM quickly or throttle position quickly. And let's go ahead and throw out where the motor is cold. That's where it's below temperature. You can look at these filters by opening this little box. And for the sake of this one, cold is when the coolant temperature is below 160. And we could change that possibly if you wanted to say 150. Save. Close. And turn it off and on again. And now we see only data when the water temperature is above 160 or 150, I guess we've changed it to. You can go to any spot in this curve and see in the upper left corner at that very point, the average every time you got there was 12.78 AFR. Go up a little higher to some other place, and 12.86 was the average. If I tag here, you will see what my target AFR was 13, where I actually hit 12.9. Another thing I could do is instead of target AFR on the left side, let's go to EGO correction. I was running closed loop on this motor, and you can see right here is a fairly orangish red, meaning we're in the 105, 107% EGO correction. That is an area that we would probably want to add fuel in that part of the map, which is 6,800 RPM, maybe 6,900 RPM, in 57 map through about 6,390 RPM and a map of 88. So basically what this does is allows you to look at millions of dots in one view. Another feature, if you happen to have MegaLogViewer HD, is histograms. Basically what this does is rolls the average together for you. Right now we're looking at RPM load. Let's change load. Hit the tag down and come down to map. Essentially the same thing. But you can make these buckets the same as they are in the tuning software, along with the RPM buckets the same as they are in the tuning software. Right now, I've got color based on hit weight. Well, I'm going to change that to value, and I'm going to have AFR in the field, and I'm going to change it to 2 digits, or from 2 digits down to 1 digit. Now you can see what the average AFR is. I'm going to go ahead and use these same filters, send transients and AFR, and I'm going to throw out cold. And now we can see that the average of the AFR as I went through that area was about 12.7, and it's about 13 for most of everywhere. You can see up here we had some spot that was showing up lean, and if we jump over to scatter plots, you will also see that area right here. Another little feature that's awful handy is if you right mouse click out in the middle, and you can see the trace, and let's go up instead of 40, which was the default here, let's go to 500. And what that'll do for you is show you where you were traveling to get there. I can also use the Control P to play, and you can watch the motor run its way around the VE map. I can also hit Control S for stop, right mouse click, and instead of 500, I'm going to change that up to, say, 50,000 dots. Force a repaint, as it's known. Then I'm going to go to there, and now you can see just where, with the blue lines, where this person operates the motor. Where in racing, he's about 4,300 RPM and above. This happens to be when he was pulling out of the off course. 50,000 is a fairly huge number. Let's go to, say, 20,000. Hit OK. Move the mouse so you get a repaint, and now you can see where he spends most of his time. This will be a real advantage if you're trying to get gas mileage on possibly an endurance car, where if you spend a lot of time right here, can we run it leaner in that area that you actually operate the car on track? Thank you for watching.